So for our audience, basically, just let's summarize here what we're talking about. We're talking about the ability to identifying objects, and back in the army time, that was the ability to distinguish between an enemy and something that is not a threat. Now today there are instead a lot of other applications, including the ability to detect movement. And you have sort of developed a new paradigm, a new technologies that combines the technology from radar with the machine learning. What are the reasons that led to do research in this sector that was not possible before?
The radar as it is like traditional type of radar is, as you said, signal processing. So I would say it's type of three-layer approach. The first layer is detecting the target. Detecting the target is a signal processing problem, a statistical signal processing problem, in which you estimate parameters. First, you detect if there is a target, and then you estimate parameters of the targets. For example, velocity, range, azimuth, and elevation. So basically, you say where is the target in 3D space? That's detection. And then you have tracking. The target is moving through space, and you have to track it through space and gather statistics on the target. That's called the tracking layer. And then on top of that, you have the classification layer, which until the recent years of AI/deep learning innovation was lacking a bit in various aspects. And that's where the beautiful AI innovation and radar signal processing is coupling together to produce a whole three-layered solution to the target detection, tracking, and classification problem.
I think just to add on top of what Nir said, what deep learning enabled us to do is basically create perception from something that before was just a bunch of numbers, of signals. So now we can actually create perception and actually have the machine understand than used to be possible at all. So basically now we can take a radar, which is not an image. A human cannot look at the radar output and understand logically what's going on, and basically have the machine brain basically make sense of it all and create an image that is actionable. For example, is the object that is flying there is a bird or a drone or an airplane? Just an example. If it's a drone, what type of a drone is it? How many propellers? How big the drone is? It can actually make more sense of the environment.